Hello students, this video is designed to help review for the third instructor exam for MAT120 Elementary Statistics. We're talking a lot about confidence intervals and about significance testing or hypothesis testing. Hopefully you tried this assignment before checking your answers, so if you didn't, pause the video, go try it, and then come back and see if you got it right. Alright, here's page 1. It talks about a drug called Zyac, never heard of it. And it tells you that 7 out of 221 Zyac users experience dizziness. It gives us a proportion here. This is a sample proportion because obviously there's more than 221 people that take this drug, and it's otherwise known as a point estimate. It's an estimate of a parameter, in this case, P, the population proportion. It asks us to construct a 99% confidence interval, and every confidence interval is calculated in the same way. We're going to try to figure out what the point estimate is, which in this case is 7 over 221, the critical value, which is going to be based on the normal curve, and the standard deviation of the statistic, which in every different case, for if it's p hat, for example, it's going to be this standard deviation calculation. If it's x bar, there's going to be another standard deviation calculation. They're all fairly straightforward. The first thing we're going to do is try to figure out what our critical value is, and that's going to be based on the percentage, the 99% confidence interval. I know that my alpha, that's the Greek letter alpha, is going to be based on the percentage. In other words, it's 1 minus that percentage. In this case, it's 0.01. If it asks for 95% confidence interval, the alpha would be 1 minus 95%. That's 0.05. I also know that if I have a 99% confidence interval, then half of 1% is going to be in this lower tail, and half of 1% is going to be in this upper tail. Remember, we're looking for a confidence interval of 99%. 99% of all observed values or observed situations are going to fall between these two values, which means there's a 1% chance that we observe something that is more extreme than these. To get the z-score, we're going to use the calculator invnorm, and I'm going to show you how to do that on the calculator now. So all I'm going to do is pull up my calculator here. I'm going to go to second dister, that's distributions, and I'm looking for where it says invnorm. Invnorm tells me the area, invnorm tells me the z-score for a certain area under the curve. I'm looking for area under the curve of 0.005, which corresponds to 0.5%. So I'm going to put 0.005. And then the next two numbers are 0 and 1. That means a standard normal distribution is going to have a mean of 0. That's the value that's right here in the middle. And a standard deviation of 1. So 0 and 1. And you should get negative 2.576. You should remember that this z-score is negative 2.576. And this z-score is positive 2.576. Because the normal curve is symmetrical. Once I get this value, I'm going to take it and put it into the formula for confidence intervals. Let's get rid of this calculator. The formula for confidence intervals is the point estimate, which as you remember is p hat. The critical value, which as we just calculated is positive 2.576. We can put negative 2.576 into this formula the same way. I'm using plus and minus here, which means I'm adding and subtracting it, so it doesn't matter which order I do that. And then p hat, 1 minus p hat over n. We're using this p hat and 1 minus p hat because we're not given a population proportion. We're given the sample proportion. If we got the population proportion, we'd be able to use it. You're going to see that later. So the calculation just gives us 0.0013 and 0.0621. This is the confidence interval. I added and subtracted this value from 0.0317 and I got the interval. The interpretation of that is we're 99% confident, 99 coming from 99%, that the true population proportion, we're looking for the true population proportion by estimating it with a sample proportion, of all Zyac users who experience dizziness, yada yada yada, is between 0.0013 and 0.0621. So that's my confidence interval. For the second question, it tells us that an instructor gives a B to students between 80 and 90. A pretty nice instructor, I'd say. The scores on the exam in one particular year have a mean of 83 and a standard deviation of 5. These are population numbers because we're talking about all of the students for that whole entire year. So what proportion of the students of the course will get a B? Well, I know that an 80 gives me a z-score of negative 0.6. And remember, z-scores are calculated. They're a measure of how weird something is. They're calculated by doing whatever the value is that you're trying to compare, minus the mean, the population mean, divided by the standard deviation. In this case, the population standard deviation is 5. So I should get negative 0.6. A 90 is farther away from 83 than an 80 is far away from 83. So it makes sense that this weirdness score, the z-score, is larger. I find the area under the curve between those z-scores by, yet again, using my trusty calculator. I'm going to use normal CDF. That's found in second distribution, normal CDF. Please note that we don't use normal PDF for the purposes of this discussion or anything else that we do in MAT120. So I'm going to put in negative 0.6. The next argument is 1.4 because I'm trying to find the area under the curve between those two values. And the 0 and 1 should be familiar to you. We did it last time. I'm trying to relate it to a standard normal distribution, which has a mean of 0 and a standard deviation of 1. 0.64499 rounds to 0.6450, and that's how I got that number. Get out of here. Hey, get out of here, calculator. My interpretation, the answer to the question, 64.5% of students should receive a B, because these are the folks that are at question. 4 students from the course are randomly selected. As soon as we have a sample, we're going to change our standard deviation. Remember, the standard deviation decreases when our n increases because our variability is smaller. First, we find the z-score in the typical way. Then we find the area under the curve. In this case, we're looking for folks that have a mean score that's greater than 84. So this 0.4 represents 84. That's the z-score for 84. And all of these folks have scores that are bigger than 84. And it keeps on going up to infinity. We use normal CDF. I just showed you that calculation on the calculator, so I'm not going to show you again. 0.3446 is our answer, and that means the probability of scoring above an 84 is 0.3446. The only difference between there are 2 differences between the previous problem and this problem. In the previous problem, we were given a lower bound and an upper bound, so we found the area between those 2 things. In this case, we were given a lower bound, and we said, well, we want to go up to infinity. Calculator doesn't do infinity too good, so we use 10 to the 99th power. And let's see, was there any other? Oh, the other difference was we have a sample here. It's more than 1, so the standard deviation is going to be calculated by finding the standard deviation of the population divided by the square root of the sample size, and that should be 2.5. Anytime you're taking a sample of greater than 1, your standard deviation is going to change. All right. In this problem, we were doing more z-scores. We found the z-scores for the weights, 0.4 and 3.2 respectively, and it's given to us that the standard deviation of the population is 25 pounds. It's given to us that the mean is 140 pounds. We found the area under the curve between the scores. Sorry, I drew my curve all crooked-like. I just couldn't bring myself to draw it straight. The normal CDF gives me 0.4 down here. That corresponds to 150 pounds. This corresponds to 220 pounds. So again, just like the previous problem, we found the area between those two bounds, and 0 and 1 for reasons that I've explained before. The answer to the question, we're talking about the probability that her weight is between 150 and 220 pounds is 0.3439. 25 different women. Now we have a sample of 25 women, so that means we're going to change our standard deviation. Anytime you have a number that's greater than 1 for your sample, your standard deviation changes. Typical stuff for finding the z-scores, we're only changing the standard deviation. In this case, it's 25 over radical 25, which simplifies out to 5. And then we find our z-score and another z-score. Notice that the z-scores up here were 0.4 and 3.2. We're not that far away from the mean, but this one is extremely far away from the mean because the standard deviation went down. As the standard deviation goes down, the weirdness of values is going to increase. This corresponds to 150 pounds here. This corresponds to 220 pounds here. The only difference between this calculation and the previous calculation is we're using our new z-scores calculated with our new standard deviation. And here's the answer to the question. All right. In this case, we're talking about hypothesis testing, which is otherwise known as significance testing. If it says test the claim, you could be pretty sure that it's talking about a test. The null and alternative hypotheses are just what you're trying to disprove and what you're trying to prove. This we call the dummy hypothesis in class. The null hypothesis is the dummy hypothesis. We're trying to say, well, we're trying to disprove this. And this is what we're actually trying to say. We're trying to figure out whether p is less than 0.5. And remember, with testing, we can't really prove much, but we're trying to test it. And you'll see that in the language later on. We're trying to test whether the proportion of adults who shop using the internet is less than 0.5, so P is less than 0.5. The test statistic for proportions is always going to be Z. For means, it depends on whether you know the population standard deviation or not. We'll get to that in a moment. In this class, we'll only be using two test statistics, either Z or T, and every time we do proportions, we're using Z. The calculation of Z is pretty straightforward. This formula is not that bad to use. Keep in mind we're using P here, which is the population proportion, 0.5 and 1 minus 0.5 respectively, and the calculation is pretty straightforward. We get negative 9.605. Then the next thing we're supposed to do is find the critical value, otherwise known as, we're really not finding the critical value, we're really finding the p-value, which is the probability of the test statistic. We're basically answering the question, what's the probability that we get 0.35 as our sample proportion when our real proportion is supposed to be 0.5? They're pretty far apart from each other, which means the probability of getting this number should be pretty low. And that's proven here. Notice that this region is very small. This is the region of probabilities that give me the chance of getting negative 9.605 as our z value or less than that. The calculator can't do it. The calculator just finds a value of 0. I mean, there's space here for sure, but it's too small for the calculator to find, which means it's very, very improbable of us getting that value from the study that we did. All we have to do here is compare the p-value, which is the thing that we just found, which is approximately 0, to alpha, and alpha, as stated previously, is 0.05. If the p-value is smaller than alpha, we reject the null hypothesis. Anytime p-value is smaller than alpha, we reject. Rejecting the null hypothesis means there's sufficient evidence to support the claim that the true proportion is less than 50%. In other words, if we reject the null hypothesis, we're saying that we have enough evidence to say that the alternative hypothesis is probably true. Last but not least, I'm not going to go over the bonus question because that's crazy talk. Last but not least, we'll do another hypothesis test. This one's talking about means, not proportions, so we're going to set up our hypotheses a little differently. We're going to be using mu in there. It says we're looking for the claim that that the mean of sugar content is less than 0.3. So mean is less than 0.3. That's our alternative hypothesis. Our dummy or null hypothesis is mu is equal to 0.3. The next thing I need to do is figure out a test statistic. If the population standard deviation is unknown, we're going to use the t statistic. And here we don't have the population standard deviation. We have S, which is the sample standard deviation. As a quick note, if the problem told us the population standard deviation, we'd use Z instead. Z is a better test to use, but we can only use it when we know the population standard deviation. We calculate t in a very simple way. It's just plugging numbers into a formula. This is the only math really in this math class. Most of it is just critical reasoning. So we got our t test statistic, which is negative 0.1190. The next thing we're going to try to figure out is the p-value. Remember, that's the probability of getting a test statistic of this value or more extreme than that. Our lower bound and our upper bound are pretty straightforward. We've done that before. The only difference with t is that we have to include something called the degrees of freedom. You might say, what is that? Well, it's n minus 1. In this case, n was 16 because our sample size is 16. It's always just going to be that number minus 1. This is something that you must remember. So TCDF of all of this nonsense is equal to 0.4534. That's a pretty high probability. In fact, when we compare 0.4534 to 0.05, the p-value is bigger than alpha. When the p-value is bigger than alpha, we fail to reject the null hypothesis. Remember in the previous problem, when the p-value was less than alpha, we reject. When the p-value is greater than alpha, we fail to reject. So here's the sentence that you need to write. We fail to reject the null hypothesis. There's not sufficient evidence as compared to there is sufficient evidence here to support the claim. So I keep switching back and forth, but I want you to really understand the comparison here. And we're just using the same vocabulary that we used up here. The true mean sugar content is less than 0.3 grams. I'm getting that vocabulary right from the problem. All right, this video was designed to help with reviewing for test number 3, the instructor exam. Good luck studying.